Yes? Yes? Yeah. Works.
So, yeah, you guys take a seat. Here is Tomáš. We will be talking about FIPS 142 compliance for developers. Enjoy.
Welcome. Let's start with a short agenda. So I will introduce myself, and I will talk about what is actually the FIPS 140-2, who should care, why you should care, if you think you should, then how to make your software compliant. We will talk more about Red Hat Enterprise Linux and its relation to FIPS. We will talk about FIPS-approved algorithms and about validated crypto libraries and how you use the FIPS mode of them, and also about future. And there will be also some demo. So let me introduce myself. I work as a software engineer in Red Hat for already almost 14 years, and working in general on crypto and security. And currently, I'm also the FIPS engineering tech lead for Red Hat Enterprise Linux. So what is the FIPS 142? Yeah, this is the definition. U.S. government computer security standard for approving cryptographic modules, and it's issued by NIST, which is National Institute of Standards and Technology, or American government institution. I have no idea what you are talking about. Yeah, probably. I think that many people here have an idea what I am talking about, but maybe there are some who don't. So let's have a short glossary. What's a cryptographic module? It's can be crypto library, hardware, or even application, software application, or mix of software and hardware that is FIPS validated. What does it mean, FIPS validated? The module validation or revalidation is process of obtaining the certificate for the crypto module. Certificate in it's actually not called officially certificate. Approved algorithm. That's basically an algorithm, cryptographic algorithm, that's officially defined in some NIST standard, and it's actually tested by the FIPS validation. Approved mode, in other words, FIPS mode, is a state of operation of FIPS module, the cryptographic module, which makes the module to be compliant with the FIPS requirements. And security level, the security requirements and restrictions, it defines the security requirements and restrictions provided by the FIPS module. Basically, the higher level, the stronger requirements and restrictions on the FIPS module. So, what actually is the FIPS 142 trying to solve? Cryptography is hard to make right. Yeah, it's very hard to make right, actually. And algorithms, if you want to make it at least somehow correctly, the algorithms must be well known and studied by large number of cryptographers. Otherwise, there is very high risk of that the algorithm is wrong and is actually insecure. But not only designing new algorithm is hard, although properly implementing it with closing ways for various side channel attacks is even harder. Even cryptographers cannot do this. This requires also special skills to be able to actually close these side channel attacks. So, and properly using already implemented crypto, even if the implementation is correct, algorithm is correct, properly using it is also hard. So, solution. Maybe FIPS 142 is solution to this. Yeah, it requires that only approved algorithms can be used. So at least the first problem, let's say it's solved. Implementation must be independently reviewed and tested by a third party. Yeah, this is at least attempt to solve the second problem. There needs to be some documentation how to properly use the implementation. Maybe not so complete. Only exactly the implementation that was reviewed and tested can be used. That the government institutions think that this is a good thing. Is it really a good thing? What if a security issue is discovered and needs to be fixed quickly? Yeah, and are actually all the problems solved? Problem of using crypto and implementing crypto, maybe not so much. But who should care about FIPS? US government institutions, maybe other regulated industries, financial institutions, healthcare, software and hardware vendors who are providing implementations of cryptography, software and hardware vendors using implementations of cryptography, maybe end users, not so sure about that, probably not, hopefully. Why should you care? If you are a US government institution, you are now required, basically by law or other directives, to purchase only such software and hardware where all the implementations of security-relevant cryptography are covered by FIPS 142. That means that basically now you cannot sell anything to US government that is not FIPS certified. Other regulated industries, maybe they are not completely required to use only FIPS 140-crypto, but still it's like they might see it as a plus if your software or hardware is FIPS certified, and especially if if this software is for like communicating with the U.S. government, again, you might have to have FIPS 140-2 compliance. So if you are a software hardware vendor which is providing implementation of cryptography, if you want to sell to us, you must FIPS certify. If you are using implementation of cryptography, your software must be FIPS compliant. This is basically the main topic of this talk, like what to do if you want your software FIPS compliant on RHEL. FIPS compliance. In general, you have to use only FIPS approved and allowed crypto from FIPS certified modules. The modules must be used according to the security policy documents. That might not be always the easiest task because sometimes the security policy documents contain so many things that you actually don't understand what it means. So you have to maybe rely on the developers of these modules that they do things right. And they basically do it right without you like actually reading the policy documents and checking all the stuff in there. But usually at least something needs to be read. To at least somehow make it easier, only security relevant use of crypto is covered. That means that, for example, if you use MD5 for hash table indexing, that's probably not covered. And maybe it's also not a good idea to use MD5 for that, but MD5 use in TLS 1.0 is also not covered because it's duplicated with SHA-1, and the security properties of SHA-1 or SHA-1 is considered approved algorithm. So again, password hashing is not covered in a way because FIPS is in general not concerned about the storage or protection of the password against the system administrator. Of course, we know that the password file can be leaked, and then, yeah, it's very security relevant if you have correct password hashing, but that's not what FIPS cares about. The security relevant crypto protection of user data, basically they care about protection of user data when it leaves the physical boundary of the FIPS module. So let's talk about Red Hat Enterprise Linux and FIPS compliance and a little bit of history. It started with NSS revalidation with Sun when we acquired Netscape. So that was actually the first FIPS validated module in that the validation was in RHEL, and I was not working with FIPS yet at that time because that was done by a different team. Bob is there. Yeah, over there. So that was his work. And then, because we had this nice FIPS validated module, we tried to converge all the crypto in RHEL to this good crypto library. And unfortunately, that did not work. Yeah. Some software, there were some successful conversions, like RPM was converted by me actually, but that was the easy task, but for more complicated things, it was basically not possible to convert. So we had to add additional FIPS modules, which were validated starting from RHEL 5. What does it actually mean to validate the module? You have to contract a lab, which is third party. That's something like in between you and NIST, because the vendor who makes the module doesn't communicate with NIST directly, only through the test lab. The test lab does code review of the software. I actually don't know how it is done in case of closed source or hardware. Perhaps the test lab has to have much bigger trust in the vendor. I did not work on closed source validation, so I don't know.
Well, it needs the code itself. The lab gets access to the code.
Yeah, but in case of hardware, they do verify the masks or well,
They get the design.
By the way, if you have any questions in between, please ask, because the talk is actually shorter than the whole time, so we'll have plenty of time for questions. You have to define a state machine for the module, which means like the module has actually state, and basically that means that if you, for example, the module does something, some incorrect operation, it won't do any operation anymore. Basically, it has to be reset or reinstalled or do something like that. But fortunately, it does not have to be reinstalled. It's restarted is enough. You have to add more things to the actual code of the module. You have to add self-test, runtime integrity check, which, for example, the runtime integrity check is a very special thing that doesn't make really sense. The purpose is not to protect the module against adversary. It's only for like hardware error check or things like that. You need to create CAFS test driver and run the CAFS test. These are the tests that basically test the correctness of the algorithm by you get some data from the lab, and you produce values that are returned to the lab, and the lab says, yeah, it was okay, it was not. And you need to do bug fixing. And that's a plus for FIPS, because in my whole time of FIPS compliance, working on FIPS compliance or FIPS validation, there were actually like 2 bugs where it actually revealed a real bug in the code, the case testing. Yeah, you need to create documentation that's presented to NIST and to public. The security policy is public document, and do other paperwork. And the lab then does the NIST submission of all this material to NIST, and you can obtain the certificate which is basically the module is listed on NIST web page as validated. So let's talk more about Red Hat Enterprise Linux. There are actually multiple FIPS crypto modules, and one new thing is that in RHEL 7 we revalidate all the updated FIPS modules in each minor release, which it makes the problem of difference between, for example, security fix and the version that's validated a little bit smaller. What does it mean to have FIPS mode enabled for RHEL? You need to have Dracut FIPS package installed. Dracut F is called to regenerate initramp FS, and FIPS equals 1 is put on command line of kernel. Now it's a demo time, so I can show you that it actually works, hopefully. Okay, so is this big enough, or maybe I will make it even bigger? Okay, so I have 2 virtual machines. There is client 1, server. We have a web server there. It should actually work. Yeah, there is HTTPD server, and the system is non-FIPS. In non-FIPS, the server is not yet in the FIPS mode. So I will. Yeah, one thing I want to do is. Okay. Let's say that I am Japanese government service, and yeah, I want because in Japan you should officially use actually non-FIPS approved algorithm, which is Camellia, and your web server is using this algorithm. Actually, Firefox won't connect to that because it does not enable Camellia anymore by default on the current versions of Firefox. Yeah, I'm able to connect to this server by wget from the client machine. If I connect by S-client using Camellia, you can see that the cipher on the top is Camellia, DHE. Okay, so now let's move the client to the FIPS mode. So we installed Rakut FIPS, Rakut F. Not sure why it's taking so much time, but maybe. Yeah. Yeah, and we add the FIPS-1 and reboot. Not yet. Yeah, we are there. Process. And yeah, this is a proc flag that shows you that the system is actually in the FIPS mode, and it should be compliant. And if I now try to connect, yeah, don't use this. No, there is no overlap of the ciphers, so I'm not able to connect. So now let's try to put also the server into FIPS mode. Again. Remote. Yeah. So now I think that the HTTP won't actually run because there won't be any ciphers to use for SSL or. Yeah, so you see that also for HTTP it works like nicely, that it won't run it with wrong cipher suit. So we make it back. Where was it? Oh, yeah. Yeah, it works. Oh. Not sure what that. I think it actually should work. Yeah. Yeah. So it showed that the system is in the FIPS mode. Yeah, it's in the FIPS mode, and yeah, I should be able to connect from one machine in the FIPS mode to another in FIPS mode without problems. Yeah, this cipher is okay for FIPS. Yeah, so that's it. Let's start. Why is it not showing? I'm sorry for this. I will Why doesn't it work? Oh, yeah. Oh, it's actually in slideshow already. Yeah. So what are the actual FIPS validated crypto modules in RHEL? Of course, kernel for basically encryption of hard drives and data in transit with VPNs for IPsec, and then there we have the general cryptographic libraries that are FIPS validated. This is OpenSSL, GNU-TLS, NSS, and libgcrypt. We also have 3 applications validated, which are OpenSSH client, server, and LibreSwan. What are the actual FIPS approved algorithms that you can use if you want to be FIPS compliant? This is the list of all of these. You can, from protocols, you can use TLS, SSH2, IKE, and IPsec combination. For asymmetric crypto, you can use RSA, DSA, ECDSA, Diffie-Hellman exchange, or Diffie-Hellman key exchange. There are some limitations and restrictions on these. I will talk about this more later. For symmetric crypto, you can still use 3DES for some legacy purpose, but you should use AES actually normally. And these are all the modes that are FIPS approved, including ECB, because ECB is basically the building block for the other modes. Or at least some of these. So yeah, there might be valid reason why this can be used. And it's also one of the things that might not be completely correctly restricted and so on by the FIPS standard. So it really does not prevent you from doing things wrong completely. For hashes, SHA-1 for some legacy purpose verification of old signatures. You cannot produce new signatures with SHA-1 anymore if you want to be FIPS compliant. You can still use it, for example, for HMAC SHA-1, which is basically a safe thing to do anyway. SHA-2 and SHA-3, of course. And there are also other algorithms or things that are approved. And this is DRBG, which is the FIPS compliant random number generator. There is a key wrapping algorithm, HMAC, and CMAC. So these restrictions I was talking about, basically any key generation must be done with validated FIPS RNG, that means the DRBG. For RSA, the key sizes were originally restricted to 2 kilobits or 3 kilobits. Now there is also possibility to use larger keys. There are some caveats. The key generation must be done with a FIPS validated key generating implementation. For DSA, Diffie-Hellman, this is similar restriction, 2 kilobits or 3 kilobits keys. For ECDSAs, Diffie-Hellman, you can use only the NIST prime curves with 256, 384, and 521 bits. In future, there is also plan for like allowing curve 25519 and 448. That's ongoing work. Let's just look at the details of the validated crypto libraries. For OpenSSL, we actually don't use the upstream FIPS module implementation. That's basically a historical reason for that, because the validation of upstream module did not align to our release schedule, and yeah, so I had to basically we used parts of the upstream FIPS code and ported it to the main to the version that we already had in RHEL. And yeah, you use a FIPS mode call to query for active FIPS mode, and you should use only the high-level EVP API calls if you want to be fully compliant. And non-approved algorithms are blocked in the FIPS mode, so you cannot use them unless you know what you are doing. You can switch this blocking off if you are basically doing this for crypto non-security relevant things. If you want to debug, if you don't want to put your whole machine into the FIPS mode, you can set OpenSSL force FIPS mode environment variable to any value, and this will make OpenSSL into FIPS mode. It won't be like FIPS compliant if you do it this way, yeah, but it will behave equally. For GNU-TLS, there is equivalent GNU-TLS FIPS 140 mode-enabled call to query for active FIPS mode, and there you, because GNU-TLS crypto is mostly implemented by calling net library, but you must not do it if you want to be compliant, because that will be non-compliant. You have to use the GNU-TLS API calls. And non-approved algorithms are again blocked in the FIPS mode, and for debugging you set GNU-TLS force FIPS mode to 1, environment variable. Yeah, if you have problem with this integrity check, you can set GNU-TLS skip FIPS integrity checks to 1 for GNU-TLS, and this will be omitted. Actually, the integrity check was the main source of like problems with FIPS, with running in FIPS mode in previous RHEL releases before RHEL 7, because there is so-called prelink installed by default, which actually modifies the binaries of the shared libraries or binaries, executables. And that means that the integrity check will fail, and that's a fatal error for in the FIPS mode, and you cannot continue running the code. And so you had to undo the prelinking, uninstall prelink if you wanted to run in the FIPS mode. NSS library has PK11 is FIPS call to query for active FIPS mode, and there you should use only the high-level NSS API calls, not because the actual low-level calls would be not compliant, because they are compliant, but they are not really meant for application use. They are only for special use, and yeah, the problem is or difference from the other libraries is that non-approved algorithms are not blocked in the FIPS mode, so you have to care about it yourself. Because, as I was talking in the beginning about the validation levels of FIPS modules, because NSS was validated at higher level than the other modules on level 2, there are some more restrictions applied to what the NSS allows you to do, and it won't allow you to do secret key operations that extract the key from the module in plain text. So all these functions will fail, and that's also problematic in some cases. In addition to setting system FIPS mode for the module, you can also put it into compliant FIPS mode by setting NSS module database to FIPS FIPS-enabled state, which is module-FIPS true and module. For libgcrypt, you can use gcrypt FIPS mode active call to carry for active FIPS mode. Again, the non-improved algorithms are blocked in the FIPS mode except for MD5. That's also a historical reason why it was done this way. But if you use MD5, it will drop the libgcrypt into non-FIPS mode. Currently, libgcrypt is used only like for GNU-PG, and so this is not so big issue. For debugging, create file etc gcrypt FIPS enabled. So let's talk more about future of FIPS validation. And future of FIPS validations is actually trying to solve some of the problems. That's the automated FIPS validation project of NIST. They try to close the gap between the security against vulnerabilities and the requirements of FIPS to run the version that was validated. So basically, once this project is completed, it will allow vendors to immediately revalidate online their modules just before they release it into their customers or public. It's fully automated or will be fully automated based on testing verification, and there will be no manual work required on the NIST side. So yeah, it's still this project is still in progress. Some unknowns remain, especially around things like the paperwork and how vendors enter this automated FIPS validation program and so on. Future of RHEL and FIPS. There might be probably more FIPS crypto modules, because if you look into Fedora, current Fedora, there are so many more crypto implementations, which really makes us headaches, but hopefully some of them can be not moved to RHEL. Maybe there will be even less FIPS crypto modules, or some of the existing will disappear because they won't be needed. Because, for example, the validation of the applications, the SSH and Libers one, is only for the key derivation functions of these protocols of SSH and IKE. If this is like moved to some of these, if these key derivation algorithms are moved into the some of the crypto libraries, we can drop these modules from validation. And we also work or partner with NIST on the automated FIPS module validation. And that's basically it. There are some links to NIST web pages and RHEL government standards page. So do you have any questions? Yeah.
So what about Fedora and FIPS? Can I use at least do testing? I know that probably not doing FIPS validated. Can I use Fedora to test my code or my crypto usage code for FIPS compliance?
Yeah, so the question was about Fedora and FIPS. It should be possible. I cannot say that there won't be any regressions. Like sometimes the FIPS mode won't work properly. Unfortunately, there is no. I don't think there is any CI for FIPS mode currently on Fedora. But of course, you won't be compliant. But for testing, it's definitely useful to do it.
If I can follow up, the code is there, so
yeah,
it may work, but you have to be brave to try it.
Yeah.
I work with crypto Android already.
Yeah. more question. Yeah.
What about PKCS 11 modules and compliance with FIPS?
Yeah, basically it depends on the PKCS 11 module. We don't like NSS by itself is implemented as a PKCS 11 module, but yeah, that's a special case. But for the other modules, it's basically a third-party thing. Are we talking about hardware? Yeah, mostly.
Yes.
Yeah.
Software emulation via soft HSM.
Yeah, it's up to the vendor who produces it. So most hardware modules will get their FIPS established. Often the PKCS 11 layer is the layer that they validate to.
Yeah, so it depends on, but soft HSM particularly, I actually don't know what's back OpenSSL. So yeah, if it calls OpenSSL in compliant way, then it would be basically compliant, I would say.
Is there any list of articles that are allowed to be used to be still compliant? You said high level. What is high level calls?
For OpenSSL high level calls, it's the EVP API. Like you use the OpenSSL in normal way. You just don't call the IES encrypt or I don't know, blowfish encrypt. If you call blowfish encrypt, there might not be even blocking on this API in the FIPS mode, but it's non-compliant, of course, to use it. So you basically use normally OpenSSL according to the documentation. There is actually, for example, the libSSL can be seen as a kind of application that's using OpenSSL crypto, and yeah, we validate it as a whole, but there is no special change in libSSL. Maybe there must be some reaction to that. You don't have some algorithms available, but yeah.
How can you check runtime if they are not available in FIPS mode?
How can you?
How can you check runtime from your code that they are not supposed to be enabled? Should you use FIPS enabled calls as you expected, or check each function if it's enabled?
Basically, the libraries don't have like special functions for each algorithm. Yeah, you basically start with give me this algorithm, and you have to check whether it's available. If it returns null or something like that, the API, then you need to react to the error properly.
So if we want to fix some vulnerability in this validated module in that stream, do we need to revalidate it?
The question was about FIPS, about vulnerability in FIPS validated module on that stream. We don't revalidate it because that would be like extremely like expensive, and we would not even like get the certificate anytime like really soon after the release of because we need to react first to the security issue, and so basically it does not make real sense to revalidate each security release of kernel, for example. That would be the worst offender of this, because the kernel has batch updates and things like that. So it's updated every like few weeks, and it won't be possible to like revalidate all the time. It will be possible with the automated FIPS validation.
And so is the government allowed to apply
They have to be reasonable. Like,
I'll kind of append to that. So I work in Red Hat's public sector with the government on some of this stuff, and it actually depends. Some people will update, some people will not. So they'll say,
some people are not too much reasonable.
Yeah. This update does not match the version on the certificate, therefore it's invalidated.
Yeah.
So, and that's why we're going through the process of doing automated FIPS certification, so that we get around that argument.
Yeah, yeah, but it's basically the NIST saw the need for that, because they finally understood that it's not possible with the current process. It's like does not work. Yeah. You had a question?
I was just curious. You said the revalidations for each minor release. So
Yeah.
does it fail sometimes? How often they provide? Does the lab provide some hints?
Well, there can be some back and forth between us and the lab. Yeah, but in case of revalidations, the failures, if there is not major update of the software from upstream rebase, it's very improbable that the revalidation will fail. The only thing could make it fail would be that NIST changed the rules, which also happens. Yeah. Yeah, there can be new guidances, new requirements on the module, and then you have a problem. But we actually know it in advance, and let's not talk about the recent problem. Okay, yeah, one more.
Can it happen that some FIPS approved algorithm is in fact less secure than other non-approved?
Yeah, I wanted to actually mention that and forgot about it. Yeah. It's true that there should not be insecure algorithms. Yeah, that at least that works well for they have good cryptographers and they look at it, and so the approved algorithms are good, but that doesn't mean that there are even better algorithms like the new ones.
For me, there is no guarantee that it will improve the security if I turn it on or in.
Yeah, there is no guarantee that it will improve your security, but it should not worsen it.
But you can disable some algorithms that are more secure.
More secure. Well, they may be more secure in future-proof way or so. Yeah, or
There are no algorithms that's known to be more secure than the FIPS.
yeah, more secure in some. The curve 25519 is probably for some sense a little bit more secure than using P256 curve from NIST. Yeah, that's true. But yeah.
Is the FIPS committee fast enough in updating the policies?
It was not that much fast. Yeah, but at least they react fast to real security issues with the existing algorithms. Not some concerns theoretical that NSAs created the NIST P curves in a way that they can hack it and so on. Yeah, so if you really don't care about FIPS about the U.S. government, probably you should use the DJB curves and stuff. But
If you're paranoid that
yeah.
NIST that the NSA has messed with the NIST algorithms, then you don't want to turn FIPS on, because it's forcing you to use the very algorithms that, if you're paranoid, you think that they messed with.
Yeah.
But other than that, it's the algorithms that the government wants to run themselves. So
Yeah, they would be breaking themselves if maybe NSA thinks that they are more credible than anybody else, but I would not be on decide like this if I were by them. Yeah.
I would like to follow up on that, because also on the things that they were known to be broken in FIPS, like the ECDRBG, which was actually believed to be backdoor. These things we don't bring in reality.
Yeah.
We exercise our
Yeah, and NIST had to remove it, of course, once this concern appeared. So, they did not continue using, specifying it or allowing it.
In FIPS mode, are you required to implement all FIPS algorithm, or could you just leave
No,
out some?
yeah, you can implement what you want, like any subset you want.
Okay, but you get to, even with the ECC case, you got to choose your DRVG. And everybody, including us, said, oh, the hash DRVG looks like what we want to do. Because
Yeah.
it's the most reasonably fast and had the most characteristics that we liked. And the ECC one, even before the issue, was like, it's slow and it doesn't look all that random.
Yeah. Okay. Yeah.
With the automatic validation, will the testing labs will be necessary?
Yeah, that's one of our questions. It's still not completely resolved questions, but yeah, they in theory they won't be needed anymore.
So I can pick my fixed cryptographic library and submit it to validation for the
Yeah.
You probably wouldn't be able to do it.
Yeah,
No, but
But
You-
Red Hat.
Red Hat will
Yeah,
be
Red
good.
Hat.
Yeah.
not me as a person. Okay.
There is something like trusted vendor and so on. Yeah. Okay. So I think that's we are already out of time, or not yet, but almost. So thank you.